So let's get started. We are ready to start for EO4SDG session. Please have a seat, please. And then I just wanted to the speakers, most of the speakers should be here in order for the presentations. And then, but we need two other chairs sit on there. Monica, yeah, you are with, yes, Manuela. But yes, as much as speakers, you should sit here.
And then after I'm done, I could.
Yeah, you can just switch. You can just switch.
With whoever's left.
Exactly. Okay. Let's. Okay. Then yeah, you're here. Okay. Thank you very much. All right. Let's start about our community event. EO4SDG initiative progress and plan for post-2025 GEO work program leverage EO and AI. So my name is Osamu Ochai. I'm from the Japanese Space Agency JAXA, and then we are joint moderating with Dr. Lijun Tsuo from the China Academy of Science. Is that correct? So because the seat is very limited, so she's sitting here. So today we have six presentations, just you can hear, and all the presenters are now here. So thanks very much for the, squeezing the seats. And then we have a 6 presentation, and then 10 minutes each, maybe 8 minutes, and then 2 minutes for the question for each. And then, but we are flexible. After that, I'm passed over to my co-moderator to have a panel discussion, and then audience question answers, and then summarize the session. This is very simple, but yes, that's our session. And then we have a slides. Who is running the slides? Yeah, but someone needs to initiate because I need to have some introductory slides, but no one there. That's funny. Okay, someone needs. Felipe, can you help? Okay, that's great. Yeah, just during the coming up for the slides. Yes, I'm also the co-chairing for the EO4SDG initiative currently in the GEO work program, and we are now planning to just a new GEO work program for the post-2025 is now under planning, and then EO4SDGs, as you may know. This is going to be a renewable, and then it's now on the one of the enabling mechanisms in the work program. Still, we need some coordination about how to run the process. So we have a kind of a quarterly teleconference to organize how to run this program. I don't want to detailed discussion about how the work program should look like, but this is we really like to hear about what you are now doing about this, and then we can discuss how the future EO4SDGs in conjunction with EO and AI is really the main topic to discuss about how we can encourage the community is being more moving forward. Okay, so let me just, this is event concept. I don't want to read everything, but you may know that the post-2030 agenda, SDGs, is going to end up 2030. So we still we have less 5 years to have a global agenda. So right now, I think the UN and the framework is now under evaluation. How much SDGs goal targets indicators are being achieved, and then some of you may know that it's not so much good progress. We have 17 goals, 200 indicators, and 200 more indicators, and target is 100 something, and then but not much progress has been made. And Earth observation is tools that making a progress, and then sometimes we can satisfy about the targets and goals, but mostly for the indicators to measure how much progress has been made for the goals, SDGs goals. So there are lots of activity currently ongoing for the GEO EO4SDGs, and there are many providers and the processors and also the stakeholder indications. And we have also engaged with the UN Statistic Office, UN GGIM. This is really important that we have been done so far for the New York City discussion on how the geospatial data can be contributed to for the SDGs monitoring and the progress for the SDG goals and targets. So we really like to hear about what's happening in your community. So because this is a very diverse 17 goals for the biodiversity, water, climate, urban, blah, blah, blah. So there are a bunch of diverse activities going on, but we really hear about the Earth observation community is quite essential, very active, and so that you need to loud the voice about we are the main power for the SDGs. So that is what I really like to do. And then given the situation is going to be changed because this is one of the big topic because the technology change, innovation is one of the other aspects because AI is coming, how we can be more proactive manner for the EO plus AI is one of very innovative elements to discuss how we can more effectively, adequately, short-term burden of the processing times and the producing about the Earth intelligence for the SDGs is one of the big topics to discuss. As China colleagues, there's quite a huge amount of the activity ability to do so at this point in time. Okay, so then this event is, again, we really like to hear and make sure about the progress which has been made through the EO4SDG initiatives, but not just only for this, we really need to characterize about what is our next steps in the situation for the going to end up 2030 agenda in next less than 5 years. So this is what we need to discuss. It's kind of a little complex situation at this point in time. Okay, so yeah, let's get started. I'm going to end up my talk, and then yeah, we have 2 moderators, myself and Lee Jun-Tsuo, and then we have 7 speakers ahead. one is only the video presentation. Okay, and then we have agenda. And then we have a panel discussion. We have 4 questions already prepared, and you are in mind how to answer those things by the Lee Jun-Tsuo is going to ask. Okay, let's get started. But first presentation is a Pat from the Esri, big company, big GIS company, not just only GIS maybe. But so, floor is yours.
All right. Well, thank you very much. This is such an important topic. The SDGs really have such potential to have positive impact on the world. And we know, as Osamu was saying, many of those require Earth observations data, spatial data, and the analytics to go along with that, to understand the goals, to understand the situation, and inform actions to advance and make progress on the SDGs. And as he was saying, that can be very empowering. And part of that empowerment is really building the capacity of many people who are focused on water or on air or on developing rural areas and access to many critical resources. So one of the things that Esri, we're a GIS software company, Earth observations, analytics company, and doing more and more with AI and GEO AI. But a lot of what our focus is too is we create the software, but we also invest in building tools to build capacity. So enabling people to take these tools, have access to data, and apply that to whatever the challenges that they're focusing on. So I am representing my colleague, Carmel Turburg, who's been involved in the EO4SDG work group of GEO for many years and leads our activities with in the SDG area. So we decided the most important message we could convey is informing you, sharing a lot of the learning and capacity development resources that are out there and available to all of you right now. So we're going to focus on leveraging those GIS tools and skills, these pathways for the SDGs and beyond. So I will run through a number of examples of this, and hopefully you're familiar with them already. And if not, maybe you'll learn something new and be inspired to go home and become a student and apply some of these resources in your own situation. As you were saying here, the 17 goals, 69 targets, 231 unique indicators, there's a lot there. And we all know that many of these targets and indicators would benefit from the information from spatial information, a spatial perspective. So they're informed by geospatial data. And once you do that, once you embrace that idea and leverage some of the resources that are available in your countries, that are available from other organizations, Esri and others, you can start to put together more meaningful resources to engage the public, to engage leaders to understand. And this is just an example of some of those countries who have embraced the geospatial data and analytics to help inform some of the SDG work they're doing in their countries. This is just an online portfolio of several different countries that have done that. So we've worked with many of these countries, and we have built this kind of online platform and a template to say, if you're working on SDGs, here is some using global data, so any country in the world could get a start with building a portfolio of SDG related data to inform different targets and indicators there. And this is just an example of the portfolio from these few countries. And if we just pick one of the countries here, Burkina Faso, you can see that there's kind of a template view. It leverages, so it's easy to replicate and then say, oh, I can use global data to look at change in, in the kind of the livestock or crops or biodiversity. But then if a country has their own data, they can add more detailed data to fill in additional maps. The templates include tools that will allow you to do that swipe to compare two different time periods or different data. And the other thing that's very nice about this template of the we call this an executive portfolio, because we try to make it executive proof. A lot of times we're asked to share information with our leadership, but they don't really understand how to navigate even a dashboard sometimes. So this is very friendly, iPad friendly. So no typing required. You can touch, you can scroll through, go back and forth between maps. And this is free and open template that any country, any organization could embrace and make their own and customize as they go along. So I wanted to give a kind of that view of, as you get involved in this, what does a kind of a final product or an evolving product look like to explore those maps. But if we step back and look at the indicators and start to think about, okay, for those targets and indicators, what kind of data would we need? Oftentimes it's common data like population data and land cover data, a lot from the satellite imagery, location of critical infrastructure, kind of where conflicts are, marine areas, protected areas, lots of the common data that your GIS counterparts, you might not be, the SDG leads may not necessarily know about this data, but if we make just a general list, then we can move into, and I know this is a bit small, but that's kind of crosswalking that list of population. Well, where do I find that population data? And assembling links to the live data from many different authoritative sources. And there's a growing collection of that data that is available. And some of that data is what's fed into those templates that I showed you earlier for a few of those countries. But how do we, click happy finger there. So then when we take that general data, how do we translate that to speak to specific SDG indicators like this 1411, the index of coastal eutrophication? Now this one you kind of get off easy because GEO Blue Planet, along with NOAA, with UN organizations come together to say, how can we take global data and do the calculations, prepare the maps that will help with this, with 1411 on eutrophication. So there's an entire collection, a hub collection of data and maps already generated to address 1411. And the same with 911, looking at rural access, the rural access index, kind of accessibility of rural populations. This is all work that was led by a following methodology put out by World Bank that's already been translated using data global data. So it's summarized for every country. You already have kind of your indicator for that topic. Same with malaria, 3.3.3, the incidence of malaria per 100,000. This one, another, like we talked about the capacity development, this is a learn lesson. We've been creating many of these learn lessons where you can go there and it'll walk you through the process. How do you calculate the malaria incidence for my country? So that's a online learning tool. You can go through that. There's another one that's in this one is a story map created by FAO that goes through the Green Mountain Cover Index and how to calculate that. So this is an interactive story map that walks you through the process. So then they have also created training materials to go along with it. 11.3.1, the ratio of land consumption rate to population growth. This is, I wanted to put this one in here. So if you're looking at one of these indicators, first you just think logically, what would I have to do to, to accomplish this? Kind of lay out your general steps, and then you can move into, oh, did I go the wrong way? Oh, no, I didn't. Sorry. And then it translates into these specific steps using those tools. And I don't know how I'm doing on time. 2 minutes. Okay, I'm going fast. So this is then translating those general steps into calculating that degree of urbanization. And this is in partnership with the EO4SDG work group, with UN Habitat and JRC. And this is a calculation that is being done now, and it may actually, it will be added to the toolkit, so everyone can find it there. And all of these resources are linked from that Sustainable Cities and Human Settlement Toolkit. And then I just wanted to say, and you brought up the AI. We're doing more and more on how can we apply AI and deep learning models to do classifications, to kind of pre-package these training models to calculate different things from Earth observations data. So you can look at solar potential, you can look at crop classifications and other things. So many of these learning models are out there and available. And this is the kind of the take home is, where do you find these? We have the SDG Geospatial Learning Lab that we've put together with SDGs Today. And so there you have all of these learning materials in one spot with the tutorials. And there are a couple different ways to access these depending on what it is that, if you just want to learn basic information on how to get started, we have 2 pathways. If you're just getting started, you click on the left, and if you're an experienced user, you click on the right, and it takes you down a different learning path. And then within there, you have different learning objectives, and you can just jump in on whichever tool or skill you want to learn today. So you can start out with exploring what are the resources in the free and open ArcGIS Online. You could click on number 2, and it's how do you build a survey? Maybe you need to survey your community. If you click on number 3, it's how do I build a map? You could go on to how do I build a dashboard, and so on. How to do some analysis. So any of these learning tools are incorporated into this learning resource. If you are a little more skilled and want to really get ideas on whichever indicator is particularly of interest to you, you can go to this page and click on any one of these goals. And it will take you to an entire collection of resources focused just on that goal. So many ways to maneuver through all of the resources that are out there that help you get to the point that helps you, kind of meets you where you are, whether you're a beginner, more advanced, if you want to learn from what others have done on a particular target, or you just want to build your general kind of GIS and analytics skills along the way. A lot of free open resources out there for you to take advantage of. Thank you.
Thanks, Pat. Really great tools, and then toolkits, and also the skills needs to be communicate to each other. Any just one question from the audience, if you have. Okay. One. Yes. Oh. Two. Yeah, let's be quick. Yes, you go first.
Yes, in the plenary before we heard a lot about trust, etc. What happens when a country sees the dashboard and says, well, wait a minute, is this the correct number for me? How do you balance the trust, local data, ownership, etc.?
Yes, that's a very important question. And what I didn't get into in all of our learning materials, we have full documentation. Like one of them referenced, this is implementing the World Bank methodology for whatever indicator that was. So we follow any authoritative source in the methodology outlined, and all of the data is documented so you can go back and validate what the inputs are. So we try to embrace whatever we put out will be fully documented and follow the authoritative source. Or we work with partners like on the eutrophication, where it's GEO Blue Planet along with Esri as an implementer, but they are the experts in the methodology and the data. So all of it is documented so you could work back to validate those findings.
Thank you. One more. Yeah, go ahead.
I was going to say that I can find you later, but okay. Because I'm building the same, but for education purposes, is any copyright thing that I need to be aware of? But
everything out and share it openly, but we also work with partners on every learn lesson that we make. We do not do it kind of in a vacuum. We don't want to build anything that doesn't meet the needs on the ground. So in all of the open solutions we build, we do it hand in hand with partners. So maybe there's some opportunity we could work together on that as well.
Absolutely. Then we will talk later.
Thank you.
Great cooperation. So let's move to the next presentation. So next one is Dr. Langela Barry Swain. So you have our floor, and then could you please introduce yourself?
Thank you, Osamu-san and Professor Zhou for putting together this very useful panel. So what I'll try to do, well, I'm a professor of economics and also research director at the Center for Sustainable Development Research at the Stockholm School of Economics. What I would like to do in the presentation now is to connect to some of the issues raised by Patricia, but also give context to the speakers that are going to be introduced in the panel later, and discuss about why are we using artificial intelligence for analysis, for data collection, and how exactly does it, where exactly it is in context of the Sustainable Development Goals, and especially when we are discussing the progress of these goals and also placing it beyond Agenda 2030. So the presentation is going to be about measurements and to system transformation in the global sustainable development as we know it. So it's about evaluating, but also discussing about how we are going to think about the post-2030 world and its agenda. And are we going to be thinking about replacement or... So if we look at the evolution of the global development frameworks, and this is work that I do together with colleagues at Indian Institute of Management in Ahmedabad, we have looked at data over time for the development paradigms or development frameworks that we've had internationally, beginning from the 1990s with the Human Development Index, then the Millennium Development Goals that came from 2000 to 2015 and developed or transformed into a more expansive, universal way of looking at development with the Sustainable Development Goals. And then with the Paris Agreement, with its focus more on the environment, and now looking at the Beyond 2030 agenda. What is it that we are doing? Are we looking at new ways of where we have to go? Or is the core of the goals same? And what we've done is we've empirically looked at this using network analysis or system analysis. And what we find is that irrespective of how we have been evolving the global development frameworks, the core of development goals has remained same over time. And so it is still about removing poverty. It is still about, at the very core of development, it's still about, basic health, education, and then we have like a continuum or a bridge in terms of finance, in terms of infrastructure, and in terms of governance. And then we have a periphery with the various environmental objectives and goals coming in, which is not truly getting integrated. And that's exactly what we are or should be looking at in the future beyond 2030. So in this paper, what we are discussing is the main message is when it comes to goals, we are not going to have a major transformation in terms of what we expect to achieve. It is going to remain similar. What we really need to see a transformation in is to integrate the environmental and other goals in a much better way, using finance, using governance, using institutional settings into the core development, into the core of development. So what are the challenges as far as monitoring the progress of sustainable development goals is concerned? As was mentioned, we are talking about 17 goals. We're talking about 169 targets, 231 indicators. But the challenges that we have are mostly in terms of the measurement gaps. And these measurement gaps are in terms of missing national data. It's in terms of weak time series that is available for different countries. It's about limited comparability across different countries and regions. And it's about the policy usability of the gap. Like you mentioned about the easy access through the iPad to the data. And so how do you make the data more accessible, more usable? The second point that I want to mention about, understanding and measuring the progress of sustainable development goals or any agenda that looks beyond 2030 is the fragmented indicators. We cannot, it doesn't make sense to measure the progress of different objectives in isolation. So you cannot look at goals as silos. We need to be thinking about development and the different goals as a composite, as goals that affect each other, get affected by each other, and hence are interlinked to each other. So fragmented indicators that only measure one specific goal doesn't make much sense. What we need is indicators that measure on the system of goals that are working together, whether they negatively affect each other or positively affect each other. And then the third point that I want to make is about weak implementation. So in terms of the measurement challenges, we also need to look about how we can make the implementation of measurement, monitoring, and the progress of these goals and governance of these goals more implemented, and hence having an impact on the ground. So in the previous session, we were discussing about communities. How is it relevant for the communities in various countries? How does it affect the indigenous populations? So as many of my colleagues in the panel are going to be speaking about, they're going to be looking at various ways in which artificial intelligence can be used for data collection or analysis. And so what we have out there is satellite Earth observations. We have use of AI in terms of processing. We have the Sustainable Development Goals dashboards as you have developed. And many of these things are to meet the challenges that we face in terms of missing data or in terms of addressing and making the data more accessible. But I would also like to point out to another recent research of ours. This is with my colleagues at IGES in Japan. And there, what we are discussing is that it's very hard to measure, to monitor 231 indicators. So whether we are talking about the Sustainable Development Goals or we are looking at beyond 2030, what we should do is also, so we have given one example in our research. This is the society framework, where we look at specifically, each of the letters in the word society stands for a principle that we use to evaluate the indicators. And so by focusing on the state or outcomes, by focusing on the coverage for the populations, looking at how well integrated the indicators are, how explicit, transparent, and clear their definitions are, and also how easily they can be measured. We have identified 52 indicators, and hence what we are saying is that into the future, we don't really need very complicated indicators. What we need is indicators that try to measure the interlinked systems more effectively, and they're relatively few, so that we can effectively monitor them. So moving on from that, I would emphasize that we don't need to think about silos in terms of measuring each sustainable development, but about indicators that measures the systems. Think about how well they can be used for governance purposes and how embedded they are in the institutional infrastructure. So what we need to do is to move away from sustainable development challenges and make a systemic shift towards integrated system approach. To conclude, I would say, or that what we have is a shared language, a common metrics, a coordinated mechanism that the Sustainable Development Goals have given us. So that is something that we need to preserve as the institutional infrastructure or institutional capital that the Sustainable Development Goals have built. So whilst we are looking towards transformation in terms of architects of achieving goals, sustainable development goals, and also beyond 2030, we don't need to lose this infrastructural capital. We need to build on it. So, and at the same time, what I'm also emphasizing then, as my final message, is that the pathways beyond 2030 then need to be system-based indicators. It has to harness the power of the Earth observation, AI data infrastructure, and governance and accountability ecosystems for monitoring the progress. But I would stop with the final message. The evolution of development frameworks over the past 2 or 3 decades has shown us that the core of development goals are the same. What we need is better integration of the layered goals that we have continuously put over the system, the core of the development, and that integration has to come, and we have to meet those challenges with the help of AI or with the help of governance or infrastructure and implementation. So I'll stop there. And if you have questions that you can't take care, you can always reach me at my email. Thank you.
Great presentation. Thank you very much, Lanjura. This is really deep insights about how we can improve or evolve about the future beyond the 2030 SDGs process. Just in interest of time, one question. Yes, please.
Thank you for the presentation. I have a question regarding the politics that are involved in the development of these goals and the indicator frameworks and so on. Have you considered them in your work? Because the way you're approaching this is a little bit of a technical and scientific perspective, which is great, but there's also these other political issues that have been involved in them in their development processes.
I mean, thank you. I think you raise a very important point. I mean, all of us are aware that important concepts like religion and, for instance, population don't even enter the Sustainable Development Goals, never did. And then given the past pandemic situation and the geopolitics, some of which is ongoing, there are challenges. However, as I pointed, the core of what we want to achieve is not going to change. So the geopolitics of it might affect the implementation, may have implications on the governance, but it shouldn't have an impact on where we want to go into the future. If we are still focused on sustainable development, if we are still focused on meeting the challenges of climate change and basic challenges of development, and I think that the persistence over time of these goals, especially the core values and some of the other layered values in terms of finance, in terms of infrastructure, in terms of environment, these have not changed. We just need to integrate them better within the limitations of politics.
I think this is a very important discussion, how we can probably communicate with the policy level and our system level or data level. And this might be, given the world changing, and then SDG is a kind of a big discussion how to support the entire community. But for us, we are the kind of a geo community. We provide some sort of information how EO data can be supplied to support for the realizing about the SDG. So we may need, let's discuss about the panel discussion more because it's a really important topic for I like to maybe after the presentation, I like to hand over to this important topic in our co-moderator. So let's move to the next one. Next one is it's going to be a pre-recorded presentation by FAO, Dr. Lorenzo Di Simona, having a recording presentation. So can you start it about the next one? Yes.
Good morning, everyone. My name is Lorenzo De Simone. I'm a technical advisor for Geospatial at FAO's Agri-Food Economics and Policy Division and team leader for EOSTAT and Estella program. And I'm also a member of the EO4SDG group. And I'm here to present from Rome today because I could not join you in person. And I would like to present two innovative solutions which I believe represent a step change in what Earth observation data can do for SDG 2, not just as a monitoring tool, but as a real infrastructure for agricultural policy and financial inclusion. As we know, SDG 2 is off track, and part of the reason is a data problem. Traditional agricultural data systems face a fundamental bottleneck. They require detailed biological inputs biophysical inputs that simply are not available in data-sparse regions, and surveys are too infrequent and too costly to inform timely decisions. So the consequence is stark. By the time a crop failure appears in a statistical table, the critical intervention window has already closed. So Earth observation big data changes this because satellite offers a synoptic repeatable measurement every week, every season, everywhere. So the question is whether we build tools that turn these measurements into decisions that actually save lives. And this is what Crop PI and GeoCredit are designed to do. So the Crop PI, Crop Potential Productivity Index, assesses what land can actually produce for a specific crop based entirely on biophysical conditions. It integrates three inputs: climate suitability at 30%, water availability as the ratio between evapotranspiration to potential evapotranspiration at 50%, and soil quality, hence pH, organic carbon, and water holding capacity at 20%. A single worst performing month or drought or heat stress pulls the entire index down, reflecting biological reality. Okay, so what you see on this slide is the live Crop PI application running on Google Earth Engine. It is publicly available and operational today. So a user can select any country. Here, for instance, we've selected India, and any crop between among wheat, maize, and rice, and any time window between 2001 and 2024. And optionally stratified analysis by farmer size or by field plot size. So in this case, the map renders Crop PI at 250 meters resolution across the entire country of India. The time series panel on the right shows mean Crop PI by farm size. class over 2 decades, and we can see that the larger farms in the 10 to 50 hectares range, they consistently outperform smallholders below 5 hectares, are direct policy relevant signals for targeting support. This is not a research exercise, it's a production tool, freely available, covering any country in the world. How do we know that crop EI works? Because we validated crop EI using 2 independent approaches. In Malawi, we used a process-based model called the DSS-SAT-CERES. We ran simulations for 70,000 grid cells for maize at a 1 kilometer resolution. Then the average simulated yield of 2.6 tons per hectare was aligned with USDA reported values. When we regressed crop EI against simulated yield across 5 production classes, the R-squared was 0.75, meaning that the crop EI could explain 75% of maize yield variability at the national level. In Ethiopia, we tested spatial agreement between primary productivity from FAO's VAPOR dataset across all districts, and every year between 2012 and 2022. And Wilmot's D-stat values ranged between 0.6 and 0.8, meaning a strong, consistent spatial correlation over a decade. And in terms also of resolution advantage, we see that the local scale, for instance, Dedra district in Malawi, crop EI reveals productivity ranges between 30 to 80 as a score, whereas existing agroecological global models, they usually identify just a single value for the entire unit, meaning that crop EI sees what other global products can't see. Crop EI is globally available and is operational across 11 countries through pilot projects, with which we try to support 3 distinct policy functions. So spatial targeting, identifying high potential low yield zones, and guiding investment in inputs and irrigation to maximum return areas like the Nigeria savanna. Early warning, so crop EI tracks dynamic seasonal shift before the harvest. In Togo's Chamba district, crop EI increased from 68 to 73 between 2021 and 2022, an actionable trend data for planners. And policy accountability, so by combining actual yields against crop EI potential, governments can track whether investment are genuinely closing the productivity gap. And finally, with the flagship example in Zimbabwe, where crop EI and Earth observation, drought monitoring are connected directly to a geospatial farmer registry system, linking high-resolution indicators to individual farms, parcels. And this work has earned FAO the 2025 SDG Innovation Award. Now let me turn to GeoCredit. An estimated 750 million smallholder farmers globally are invisible to the financial system. Not because they are poor farmers, but because traditional credit scoring requires historical financial behavior, formalized income, and tangible collateral. They have none of this. So the result is information asymmetry and credit denied. But here is the key insight on the right-hand side of the slide. A farm depicted by the satellite is visible, even when formal financial record is not. Hence, satellite data can reconstruct the planting history, the climatic risk exposure, and seasonal crop performance for any georeference farm. This is a credit profile. GeoCredit asks, can we use this visibility to break down the wall? To test this, we ran a proof of concept pilot in Kenya with Mukulima Score 360, a credit scoring platform startup, national startup, using 95 anonymized smallholder borrower records and strict data governance protocols. We built 2 parallel models, a baseline using only traditional financial variables and an Earth observation augmented model, adding satellite-derived features including NDVI time series, enhanced vegetation index, leaf area index, and rainfall anomalies. The results are on this slide. So the Earth observation augmented model achieved an area under the curve of 0.846, which is an industry standard for excellent discrimination. That is an improvement from the baseline of 0.776. Cross-validation variance dropped by 36%, meaning that the model is not just better, but it's more stable. And the key Earth observation predictor was NDVI minimum, hence the vegetation stress indicator capturing the worst month of the season. And if you look at the FICO band calibration, farmers in the exceptional band predicted by the model had a 0% default rate in the record that we had from the Mukulima score. Farmers in the poor band, so predicted to be in the poor band, actually had 83% of default. So clean monotonic discrimination from a satellite signal. Now, these are preliminary results because 95 records is not a large sample, but the direction is clear and it's consistent. Kenya is the proof of concept. The next phase is scaling. So in Zimbabwe, we will leverage FAO's existing geospatial farmer registration system and the Estela program, connecting credit scoring to infrastructure that is already operational. In Brazil, we will test the model in a more formalized smallholder context. And in China, we are in dialogue with CBAS and National Agricultural Finance partners for large sample validation. So the timeline is 2025 has been the pilot with 95 records. In 2026, we are targeting scaling up beyond 300 records per country. By 2027, the goal is integration, so an open source methodology that financial regulation and lenders can adopt globally. So crop PI and GeoCredit together teach us three things that should guide the post-2025 GEO work program. So first of all, data must become decision. The pixel only matters if it's linked to a subsidy, an early warning, or a lending decision. So invest in decision pathways, not just the data pipeline. Secondly, innovation must become institutions. Measure success by embedded adoption in national statistical systems, credit scoring systems, or financial system, rather than by research publications only. And silos must become integration. So the ultimate goal is a farmer who
Okay, thanks for Lorenzo. Given all the time, yes. I think this is a great presentation. I think this is a really beyond the For me, this is a kind of one of a very innovative approach, not just only for the EO as a monitoring system, but also connecting to the next, decision-making process, including about the crediting. Crediting is one of the big potential perspective, and the FAO said about this. FAO trying to do this innovation. So this is one of the UN organizations trying to do this. So let's. It is pity just that he cannot be there, but I think maybe insightful, and then you can discuss at the panel discussion as well. So I'd like to. Next, let's move on to the next one, Dr. Ray Huang, and then you have a more focusing on the AI and the big data. So.
Yeah. Okay. Thank you, Chair. And we know that 2030 is approaching, and we are my topic is about big data and AI-based SDG indicator system, and we try to build a new SDG framework using big data and AI, and we try to play a more important role for Earth observation and AI to play more important roles here. And the background, we know that the global SDG is far off track, and only about 35% of indicators are on track. And the data gap is still a huge challenge. Only about 50% of targets have trained data during the last 5 years. So the problem is more serious in low income and global south countries. For example, for the least income countries and in the least income countries, they have the least SDG score. And for the small island countries, developing countries, and Middle East and North Africa countries, they make the slowest progress during the past 10 years. And besides, the low-income countries lack sufficient ability to obtain SDG countries. We know that they need more data, but they have lower ability to obtain SDG data. So this is the background of the data. And in China, there is another problem that using big data and statistics, we have evaluated about more than 200 SDG indicators last year. However, there is another knowledge gap because sometimes the government may ask, what should we do next? How to promote the SDG indicators in a whole? But at present, we can't give a systematical answer because there is the drivers of the different kinds of indicators and too many indicators, and we cannot provide systematical paths in the future. So that's a problem in China. And for the global scale, we tried to use big data to evaluate the global progress using big data and AI. However, it's very, very difficult. Last year, we released a report that using big data and AI to evaluate the progress using big data, we found that only about 15 indicators can be evaluated. And the progress, so there is a great lack of global consistent and high resolution data. Okay, this is the problem of different countries and different cases. So based on the problems, we need a new SDG indicator systems. For this new system, we can use the big data to cover all of the person and all the pixels in the world. And the data should be updated frequently, maybe annually or even monthly. And we should know clearly the interconnection and influential factors of each indicators rather than a progress of a single indicator. And in the future, we want to know the future of each indicators. So we should enhance the ability to predict the indicators and then make decisions for decision support for the government. And finally, we should build a strong digital infrastructure to support for each country and each person can access this data. So based on this reason, we try to build a new big data-based indicator system and a new digital infrastructures. Then finally, we call it an alive SDG system. For the big data indicators, we at present we divided it into 6 areas, including the energy, urban, and agriculture, which are more related to human activity and human life, and also water, climate change, and ecology, which is more related to nature environment. Based on these 6 areas, we plan to define about 100 indicators. Then about the digital infrastructure, it includes the satellite and cloud computing and AI. These infrastructure are aimed to make more frequent update of the data and higher resolution, higher accuracy, and automatic prediction. Then finally, we try to fulfill the SDG goals, means leave no one behind and leave no pixel behind. I will introduce some progress of recent work. And last year, our institute, CBARS, have launched an global international cooperation program named the DSP. It has been launched and endorsed by UNESCO last year. And For the satellite, we have launched SESat-1 3 years ago, and the data was shared more than 100 countries. In the next years, we will build the global SDG satellite alliance. It includes the virtual SDG satellite alliance, and we will launch about 3 new satellites about different SDG goals. For the digital infrastructure, we will update the cloud computing into the cloud computing and AI together, and enhance the ability to the scenario simulation and decision support. Here I will give some examples of how to define the SDG indicators based on big data. For example, in the old systems, about 30 SDG indicators 13.1.1, it's only related to the number of deaths in disasters. However, in the new system, we give more details of the disasters. We classify the disaster into drought, for example, for drought, for flood, for heat waves, and this is give more refined information. For some other indicators, for example, SDG indicator 1.1.2, we continue the existing SDG indicators. And for SDG indicators 13.2.2 about the greenhouse gas emission, we newly established a new indicator about the progress of carbon neutrality about the world. It can be evaluated using Earth observation. So this is the example of the areas of climate change. And this is an example of the indicator about land degradation. In previous work, it is about one value for each country. But in the new framework, we can give more details of high resolution details of different pixels. And it's not about just the monitoring about the state of the indicator, but also give the drivers of the indicators and the reasons why it is like this, and give more ability to predicting to support the decision making. Okay, at last, this is and the program is at the very, very early stage, and it includes the new indicator system and a new digital infrastructure, and we will share more and public good, and we would like to invite all of you to join this program, and it's at the very beginning, and we like to invite all of you to join this work. Okay, thank you.
Thank you very much for your really great presentation. And then this, even you are proposing a new framework as in the SDGs. One question from the audience. Any? Okay. Okay. Let's have a more discussion in the panel. And then I think we have two more presentations. Plus, after that, we have a panel discussion. So maybe we can I ask to allow about maybe 10 or 15 minutes to extend our session. It's okay. Okay. All right. Okay, let's go to the next one. Is Monica and Manuela, you are from the European Commission? No, not the Commission. Yeah, ask. And also the CMCC. So you have a problem.
Yeah. Thank you, Sama, for the introduction. And the fact that Manuela and myself are coming here is just to show the teamwork. Different stakeholders are providing different capacities. And when we talk about the Sustainable Development Agenda, this is a realization. One actor is not able to cope with all the complexity that the SDGs is bringing. And Rajula was addressing that already before. So research institutes like the European Mediterranean Climate Center in the CMCC Foundation, they European Association of Remote Sensing Companies, bringing the operational side, because the companies are more are in direction of this line of the last mile that had been discussed, but others that are research institutes that were involved in these discussions. We wanted to come here in a tandem approach just to show the dynamism of these discussions on the SDG. It's an alive discussion. It is a multilateral discussion, but it's a voluntary reporting. And probably with this voluntary reporting, maybe is why we are lacking back a little bit behind. And this is bring maybe the connection that we will make later, that the Sustainable Development Agenda needs to be also interconnected with other agendas, the skills, the Pact for Skills, their digital agenda that they are discussing also at the UN level in New York, another agenda. So it is the SDGs, the Sustainable Development Agenda, but how that are coping with another agendas. So at the European level, we have been trying to put forward an enhancement of the Copernicus program, but not only it's about satellite-derived data, but other data sets that the different organizations are bringing together. And with that, we wanted to have this scientific approach, which will give validation, the technical part that will be maybe the platform and the tools, and then the operationalization, and obviously with the framework of the co-design approach. And when I say that about the co-design approach is that the different stakeholders need to be together to discuss. So we stop it a little bit at the beginning thinking, okay, we need to understand the needs. There was the needs that Sanjula expressed at the very global level, but at the localization level, we wanted also to make a step further. We go from the local, the regional, and also the global. So we wanted to do this bottom-up approach. Data fragmentation, so obviously there is risk related these interoperability issues to the different platforms, the institutional inertia. We know that the Sustainable Development Agenda is somehow, the mandates for that is the statistical community. The statistical community have a different modus operandi, and I will say that the geospatial community. So there is a sign of understanding between the institutional dimension, but also the inertia. So for adopting new methodologies, they need to understand about that data sets and how these data sets should be integrated. And maybe there are topics here about validation, uncertainty of the data sets, etc. So we need to have this information on go for moving a step forward with this institutional dimension. The local capacity gaps, when this is about the capacity building. I mean, the NSOs, National Statistical Officers or institutes, they are not working only with the full set of indicators. They have the mandate to report on some of those, but others are coming from other organizations. So there is this capacity gap that maybe between the Environmental Protection Agency in Ireland could transfer this information to the custodian agency and the custodian, the National Statistical Office, and then go on out from the voluntary national reporting. So the complex exists and the expertise is needed. Then it's about the validation and common metadata. So this is fundamental for building trust. It's not only trust on the stakeholder that they're producing the data, it's in the methodology, in all the pathway, and then it's the long-term sustainability. So with this understanding of these needs, we came into the focus. So what we need to do with the different stakeholders that I mentioned before, we thought that a visualization or maybe easily interpretation for this new community is something that is needed. So let's go for that visualization easy pathway. The replication workflow. I mentioned that we started with pilots in different regions in Europe with different realities, focus on the sustainable goals, but they're looking more in the environmental dimension. Try to see from the local part, we will go from the national part and then scalable to Europe. When we have the dimension about Europe, Eurostat has a set of indicators that are not matching one-to-one with the UN SDGs indicators. So there is another complexity between indicators at the UN level and indicators for Europe that are driven by Eurostat. So you need to connect that set of information. Then it's about the timeliness or the special rate. So there is a potential evolving of this set of indicators, and through the technology we could move above. And then it's about the quality assurance. We wanted to be sure that the data that was ingested has all this uncertainty traceability. And now Manuela will explain a little bit about the activity. Sorry, I went to... Okay.
This is the methodology of the SDGI's project, and it's as already mentioned by Monica, it's based on three main pillars. One, it's science-based development because we want to build a robust SDGI. So we have the definition of SDGI, but for this project, we had to address Eurostat SDG. So we have to be sure that we can fit this the exact definition, but we want also to be to answer the policy need and the need of national statistic offices and the reporting agency on SDG. So we really want to do something that it's related to user needs, as well explained by Monica. We want to build up a framework where we to give trust information, and this indicator should be demonstrated on pilots area. So the concept of the project was to bring together different actors, scientists, stakeholder community, and industry expert in Earth observation. And we base mainly on most use services from Copernicus family of products, because first it was a European Horizon project, and we aim to boost the use of the information that we have from different services like Copernicus services, emergency and marine services. And we use, of course, we integrated this information with all other in situ information that are needed to describe well what happened at the local level and for society and for economy as well. And we address few of the existing indicator, and we focus really on the three targets. So we focus on the climate action, on the life on below water and life on land, and we just focus on 7 indicators. So we selected 3 indicators from climate action. One, it was related to the GEO emissions from land use and cover sector and forestry sector. And another one was on the deviation, temperature deviation from cities, from urban, and one it was on the climate impact on human population. And we had for the life below water 2 pilots on eutrophication and acidification of North Sea. And finally, we touch the more standard indicator for life on land, so the change in forest area, and the last one on soil erosion. So, and since these are the area where we tested this indicator, and we tested this indicator in this area because we were sure that we have local information and good connection with stakeholders, and they were engaged directly in the development of this service, and we applied a very good agile methodology that is typically used for technological development, but we adapt this agile methodology for the development of the service with stakeholders. So we get them engaged on the development of the service and the indicator since the beginning. And also we ask them data for validation, because another important part is the validation, so to get to give trusted information and data. So maybe if you want to say something more about the co-design.
The co-design approach has been as a typical one, but we have this agile approach. So any user requirement was embedded into the discussions. But the comment here is about the policy integration, and that was crucial to get them on board, and also to think that maybe the different organizations, different authorities that could be there, like the Carabinieri in the forest protector bodies, they will take it on board, this information, information to be able to report later on through the local authorities about how much greenhouse gas emissions for forest fires were implemented. So the policy integration was crucial from the very beginning. Just very quick on the how we then, or with all this knowledge, we put it into a platform. So we have this. I don't know if it's running, but okay. Well, there is the, you will see an animation, but otherwise you can go through the website, that you have this like a kind of back end and then front end. So there will be expertise that they would like to test their own data sets. So you will be able to go through the Python approach and then investigate with your own data. So that will give the opportunity to be the service scalable in other areas. So you take the different examples and you could run around these new data sets, the geolocation, and they will give you results. That was very valid because we, in the validation process, we put these webinars on board, and we were having people from the different regions in Europe testing this information through the local end. Manuela will go from the front end now.
Yes, this is another video, and this is the explanation, an example of the front end for the indicator on GHG emission from forest fires. And this is the front end where you can select the year for the emissions and the region and the specific events. You can run it and you can get a map of all fires in that region, and you can get also information about which is the gases emitted for these fires. And we have CO2, methane, and other emission, and we have also the emission for each plant functional type of each type of forest that are burning this fire. And you can download the data using different methods. This is a standard CSV Excel file where you can have information about all fires events and with all gas species that with the concentration. But you can export also maps that are easily uploaded in GIS software, and so you can download the map shape files of the burn area with all attached information about the emissions for the specific fire. You can download and upload in your website. And this tool, it's mature enough because it can run at national level, so you can get all this information for whole Italy. And again, it interpolate also other information. It's not only about burn area and emission from that area, but you can have also information about which species are much more affected by the fires and which is the area of forest lost by these fires. So that's and this is the methodology standard and for all the tool we developed. And so the main conclusion are that we provide a very easy, intuitive and robust mapping of interesting SDGs, and the design, it's a replicable, scalable workflow. And we increase, of course, temporal resolution because we need timeless reporting, and mainly during we need interannual variability as well. And we improve a spatial scale using our resolution data when possible. And of course, we always try to enhance the accuracy of the methodology because we really take care about the accuracy on the technology, on the data workflow and methodology, but of course in the validation because we put a lot of efforts on that as well. Thank you very much for listening.
Thank you very much, Monica and Manuela. You are really comprehensive tool has already been developed about this. So this is really excellent. You have done quite a lot. So because running over time, we really like to extend our session, maybe 10 or 20 minutes. Sorry about that lunchtime. However, we still have one more presentation. Last but not least, I'd like to introduce Genki Terauchi from Japan. And so you have a floor.
Thank you. I hope you are not hungry. I try to be quick. Okay. Okay, my talk is about SDG 14, and I will be introducing my project working with JAXA. This map shows the program that I work for. We are the part of UNEP Regional C program and Northwest Pacific Action Plan and the program that China, Japan, Korea, and Russia joins. And we have more than 20 years of history there. And we are the ones producing satellite-derived chlorophyll A dataset because it's important indicator for coastal eutrophication, because one of the response to eutrophication is excessive growth of phytoplanktons, and that is visible from the satellite sensors. Today, we have so many satellite sensors. And in this platform we developed, we have been using NASA SeaWiFS, NASA MODIS Aqua, which is in operation today, has more than 20 years historical data. And we have been using ESAR ocean color dataset, and of course, JAXA dataset. So even like expert like myself, sometimes get confused. There are so many datasets available today, but policymakers do not really need to know the difference between these different sensors. So what we are trying to do is to blend all this data set to make one times lease that is necessary for our assessment of coastal eutrophication. In working with UNEP, we have contributed our work, and in this manual published in 2021, there are chapters to describe about how we use this chlorophyll concentrations. And there are two different levels that the chlorophyll concentrations are believed to be useful. And the level one is like a global level. And because we work for regional seas, we work specifically on level 2. And there is another chlorophyll concentration value in there. Okay. So we started our work on a small scale, from local scale, then to a regional scale, and then somehow end up doing on the global scale assessment. This is our history in NOPAP. We started developing our own database to have time series of satellite-derived chlorophyll, and then it took some years to develop the methodology for assessment, and came up with these 6 colors you see on the screen. And I will show you how it works. Okay. So everything starts from daily or pulse observations. Today we have every day based on a daily basis observations. But at the end, like policymakers like to know what's going on in our ocean, right? So the logic here start with daily composite and then monthly composite. Once the monthly composite is ready, we ingest those data sets into Google Earth Engine. We partner with Google. And then once the data is ingested, we calculate the recent 3 years mean of the satellite data, satellite-derived chlorophyll level. And then at the same time, we calculate the interannual trend of each pixel locations. One location you see decreasing trend of satellite chlorophyll, another location you might see increasing, and sometimes there are no trend at all. So by combining the level of chlorophyll and the interannual trend of each locations, you can make one map. And this is our system. And now I want to talk about why we need JAXA SGLI. Using global data sets available today, often you get 4 kilometers or 9 kilometers very sparse spatial resolution data set. But eutrophication occurs in the coastal zones most of the time, so you need higher resolution satellite data set. And with JAXA ocean color data set, you can get 250 meter spatial resolution in coastal regions. And this is an example in the southern regions of Japan. So now we work with Ministry of Environment, and we are trying to tell the ministry that, okay, let's try to make SGLI data set very useful to monitor our waters. And that's the light purple you see on this map is the territorial sea that claimed by the Japanese government. And we are trying to monitor the ratio of these 6 colors and trying to produce this map on an every year basis. So in this particular case, well, you need to get close to the map to find out this red color pixel, which is the red means the chlorophyll is higher than 5 milligram per cubic meters, and it's been increasing. So we are taking that red color pixel ratio against the regions of interest. In this case is the Japan Territorial Sea, and reporting the numbers to our government. That was a case of Japan, but we work with on a global scale with partnership. We work with Google. We work with UNEP, World Conservation Monitoring Center in Cambridge, and we work with Latin American scientists who really cares about the coastal eutrophication phenomena. And today I would like to announce a new platform as a result of working with UNEP WCMC. This data set will be made ready within the next 2 days. So you will see coastal eutrophication potential data layer at the UNBL. At this moment, we are ingesting and we are using ESAR climate change initial chief data set, which is 1 kilometer and 4 kilometers. But this year we have a plan to make JAXA 250 data set available on the global scale. Thank you very much for your attention.
Thank you very much, Genki-san. So much a great, really, very sophisticated presentation in terms of the eutrophication, which is our cooperation in Japan. So let's move on directly to the panel discussion because we are running out of time. So I'd like to switch over to my fellow co-chairs. So yeah, please.
Okay, thank you. Hello, I'm Li Junzuo from CBAS. So the time is very limited, so I will be quick for this part. Just now, our speaker have present the need and how the EO and AI technique can empower the monitoring of SDGs. And now, as we are have passed 10 years of SDG, we only have 18% SDG, which is on track, and 50% of the data is lack of indicators is lack of time series data. So except for thinking how to use the EO and AI technique to monitoring the SDGs, I think we should also rethink the SDG indicator system itself, if it is suitable for us to move forward. And I would like to summarize the 4 questions into 2. So first is based on your experience, have you come across some problems when you use the EO or AI technique to monitor SDGs, and what do we think? What kind of improvement that we can promote to the SDG systems? And second is that it's more maybe we can bring the science out of the ivory tower. That is how the private and public partnerships can contribute to the implementation of the SDGs, and how could we raise fundings for our activities. So maybe we will go Patricia first. Yeah.
Yes, thank you. I mean, it's big questions there. Big questions there, but I think we have a lot of great ideas on this panel. And I think in terms of, well, the first one in kind of examples of using EO and AI. I think I gave a number of those. One of the areas that we are focusing on now is creating these AI models, pre-trained AI models. I think we have put out over 100 of those now based on kind of training models to find specific things, and many that address the SDGs, and those we make openly available so people can kind of jumpstart to get further faster. And I think having those pre-trained models, more of this data open and available, and then marrying that up with those training materials we talked about, hopefully we can amplify the effort and everybody moves further faster, whether it's using AI to identify the solar potential, or look at crop stress, to look at some of the proximity issues of rural development and access to roads, things like that. They're very well suited for those large models. In terms of taking it out of the ivory tower, I'm totally with you on that. And something that I think we've seen examples here on the panel, and we too, trying to create those executive tools, make those the data and the outcomes, the learning, more understandable to the common people and not just the scientists, and do it in that. And I think what we bring from the EO GIS world is that the value of a map and being able to see the change, the relationships, and help people relate to what's on the ground there. I think the tools are there to do it. I think we've seen some more examples there, and it's certainly we're putting more and more out and working through the EO4SDG working group to share those.
Yeah.
Yep. And I apologize, I am late for my next thing, so I might slip out.
Okay, please. Thank you for your insights. Yeah. And then maybe Ranjula, you can share your insights on the questions.
Thank you. I'll just keep it brief. I think it's important to integrate the methods of AI, whether they are for monitoring, data collection, or analytical purposes, with the other traditional ways of data collection, and also non-traditional new ways of data collection. And some of these data collections are mandated to the National Statistical Organization. So how do you integrate those data? And the reason why the integration is very important is because we can't just look at one indicator, just environmental indicators of some kinds, and then use them. The data frequency, the data resolution, granularity is different. So we need to integrate it with other data systems to understand the interlinkages within the different indicators for gauging the progress, and also understanding how policies can be designed for the progress of the system. I don't think it's just one thing we need to. So I'll stop there. Thanks.
Yeah, there is no one single data can salute all the problems. So we need the integration. It's very important. So, Dr. Huang, do you have any?
Okay, I will respond shortly. I think the largest challenge at present is that when we use different data source, different satellite or different data source and different AI models, it's possible that we get different answers or different results. So I think most urgent work is to how to reach an agreement globally to choose the best, maybe the best or acceptable data source, or AI models to make the global standard and global agreement for each indicator. I think, yeah, I hope it is possible.
Okay, yeah, the standard of the methodologies is very important. That make us can compare different results, different something that can draw a conclusion. Yeah. Okay.
Yeah. We have been discussing about that integration, but for me, I will keep the question about the public-private.
Yeah. I think you are the good.
there, so we'll pick the other one, which is complex, by the way, because here we need to see which is the stakeholders typology here. We're thinking that maybe the SDGs framework could sit together with the ESG framework. The ESG is environmental corporate responsibilities. And this is when you have the private sector on board. You have energy companies, insurance companies that they need to report their obligations. So somehow it's to matrix these frameworks with another existing frameworks that somehow maybe there are other type of regulation there. And in fact, in Europe, we have regulations related to corporate sustainability and they need to report. So we see that there will be the mobilization of the framework itself, but more importantly, also the financial system, and they will put the investment to mobilize this framework. So I think the partnership, I think is very feasible that you can partner public institutions and private institutions, thinking in maybe bridges, the other type of organization are bridges to other communities, not that the government will fit already with the energy sector, but they are the EO community to could help the bridge. So I see this connection is quite needed. So that was my point.
So about the data integration, so it's in my point of view, it's very important also to see which is the level and for what we want to use artificial intelligence in the process, because we saw also in the plenary that there are very good examples for the use of artificial intelligence for change detection maps and for classification. That's very powerful things. But if we need to more complex processes that lead to the definition of SDGs, like soil erosion, there we need more integration of different data and process. And sometimes this process are physical based. We can try to maybe cover or describe with artificial intelligence some part of the process, but maybe not the full process. So I see also there the good integration of Earth observation and artificial intelligence to have a new, like a forecast climate variable for rainfall, erosivity, or for fires spread or something like that. So I see really these two parts of the development, but of course we need really to clarify in the workflow, which is how we use artificial intelligence for doing what. That's
that's true. That we need to integrate the EO and the AI together to implement the SDGs, and also for different for private sector and the public sector, they have different roles in this process. Maybe the private sector, they will be more close to the users. They know what exactly we need to do. Then the combination should be accelerate the implementation of the SDGs. And then, Jenk, please.
Thank you. So my experience using AI, I believe it is very useful for validating the input data. Especially today, we have so many different sensors and intercalculation among different sensors. I think AI can play a big role here. But at the same time, we have to be very careful. Like when we try to use AI for data interpretation, I think sometimes you get really wrong information, and this is not very useful sometimes. So, and that's where we need to work with local scientists through communities, because they are the ones who has the knowledge. And I think humans should play a big role here to interpolate the information we get from Earth observation data. Thank you.
Yeah. we cannot get the one solution for all. So it is very important to relate it to local people, the local experience in the estimation of the SDGs. Yeah. Okay, yeah, I think it is time for lunch, and we really appreciate for the audience participant, and I will ask us all to appreciate our panelist speakers, yeah, with applause. Thank you. And do you have anything you want to add?
No, that's fine. Yes, thanks so much for participating. We're all hungry. And then I just wanted to know, because the EO4SDG is still up and running. So we like to continue to discuss about the involvement of all the partnerships to further down what we have discussed in the future. So thank you very much.